Hi ladies and gentlemen, so today we're taking a look at 3.5, finding real roots of polynomial equations. So as we talked about in Unit 3, we know equations have real zeros of where it crosses the x-axis and imaginary zeros. So today's lesson is going to be focused on finding those real zeros of where it crosses the x-axis graphically if we were to do it on a calculator. So in our warm-up, I want us to practice our factoring skills before we get started with finding those roots. So taking a look at the first one, we have 2y cubed plus 4y squared minus 30y. So if we kind of pull that off to the side, notice that every single one of these terms, the 2y cubed, the 4y squared, and the minus 30y, all have a 2 in common, meaning they can all be divided by 2. What also is in common among all three terms is the y. When I factor the 2y out from each piece, I had 2y cubed, I divided by 2y, and I'm left with y squared. I had 4y squared, I divided it by 2y, so I'm left with 2y. I had minus 30y, I divided out a 2y though, so I have minus 15. Now I'm left with something that appears to be a quadratic here inside my parentheses, y squared plus 2y minus 15. So I have to think, how does that factor? What are the factors of negative 15 that could also combine to give me a positive 2? Well, that would be plus 5 and minus 3. Notice how all of my factor pieces are linear, meaning they're y's to a power of 1. That means this is as factored as it can possibly be. Let's do the same thing for part B. I have 3x to the fourth minus 6x squared minus 24. Right off the bat, I'm noticing all three of those pieces have a 3 in common. They're all divisible by 3. That leaves me with x to the fourth minus 2x squared minus 8. So now I have something that is 3 terms, and I can split it up. So x to the fourth can be split up into x squared and x squared. And this works because my middle term is x squared as well. And so because x to the fourth can be split into x squared and x squared, and my middle term is x squared, this works. It works in the same way as a quadratic does. Okay, just how we split up the 2y, okay? It works in the exact same way, just it's to the power of 4 and power of 2. So now I'm thinking, what two numbers multiply to give me negative 8, but add to give me negative 2? And that would be minus 4 and plus 2. X squared minus 4 is a difference of 2 squares, which we talked about in 3/4 lesson. So that's like saying x squared minus 2 squared. So my final factor form is going to be 3 times x plus 2 times x minus 2, and then x squared plus 2. So the x squared minus 2 squared factors into x plus 2 and x minus 2. But overall, our final answer is this piece all the way down here. Now I know we have an x squared term in that last factored piece, and that's okay because x squared plus 2 cannot be factored any further. So now let's take a look at our objectives. So today our objectives are to find roots of polynomials by factoring. So we're going to do exactly what we did in this warm-up problem, but we're going to take it a step further where we go and solve for x. So in example 1, we want to solve the polynomial equation by factoring, and you can always check your results by graphing to know if you did it right. But the goal here is to do this algebraically, hence this being an algebra course. So starting off, we have 4x to the 6th plus 4x to the 5th minus 24x to the 4th. Very first thing we want to do with all of these problems from here on out is ask ourselves, what is the greatest common factor between all the pieces in this equation? Well, each of these pieces can be divided by a 4, and they all have a variable of x attached to them, so I can factor an x out as well. The greatest common factor for the variable is x to the 4th, because that's the smallest degree term at the end. So I'm going to factor out a 4x to the 4th. So I had 4x to the 6th, but now I'm factoring out 4x to the 4th, and that leaves me with x squared. I had 4x to the 5th. I factored out the 4x to the 4th though, and that leaves me with a plus 1x. I had minus 24x to the 4th, but I am dividing out 4x to the 4th, so that leaves me with minus 6. Again, you can always check your work by doing this process backwards and taking this 4x to the 4th and multiplying it back in, and you would get the original problem at hand. But the purpose of this is to factor, so I'm going to erase that work. Now from here, the x squared plus x minus 6 is a quadratic that we can factor. So what are two numbers that multiply to negative 6 but combine to be positive 1? And that would be x plus 3 and x minus 2. And then the 4x to the 4th is going to carry down. Now, it's as factored as much as possible, meaning I have this written as a bunch of pieces multiplied together. And when that happens, we can apply what's called the zero product property. That says, if the product of a set of numbers is 0, then that means each individual number has the option to be 0. So we're going to say for x to the power 4 equals 0. We're going to say x plus 3 is equal to 0. And then we're going to say x minus 2 is equal to 0. Solving for x on the first one, well, we have 4 times a number equals 0. So the only option that number can be is 0. Math-wise, though, if you want to see the reason behind it, we would divide by 4 and get x to the 4th equals 0. So that means x equals 0. X plus 3 equals 0, we would subtract 3. So x equals negative 3. X plus 2 equals 0, we would add 2. So x equals 2. Every year I have students say, Mrs. Walker, what is the minimum amount of work I have to show to earn credit? Well, I need to see your factoring process in your completely factored form, and I need to see what x is equal to. It's okay if once it's in factored form, you don't show me the little steps in between of how you're getting what x is equal to.